Welcome, guys. Here we have another question based on another topic. This topic is actually based on partial derivative. So, considering the question we have here, trivially, we can easily see that the question says given g of x and y to be equals to this expression, where x and y are the two independent variable for the function, such that we are now asked to find the following: del g del x and the second derivative partially with respect to x, and then for the question C and for question D. So the solution to this is very direct. So considering the first part of the solution, the question says find del g del x. That is, this thing can be written as, you can write it as del of g, where g, the complete function for g is this. This g can be written as g of x comma y, okay, over what? Del x. You can also rewrite this as del x of the function given to us. That is, I'm trying to differentiate this function partially with respect to x. So that's how it works. And then this will give us del x of what is the function given to us. That's g of x and y, which is x raised to the power of 3 plus 2x squared y cubed minus 3y squared plus 11x minus 12y. So when you have this, what's the next thing to do? Trivially, we need to differentiate partially with respect to x for each of the terms we have here. That is, we end up having our del g with respect to x, del x of the first term we have here, which is x cubed. So you do the same thing for the next one. Del x of 2x squared y cubed, right? Then you do it for the next one too. Del x of 3y squared plus del x of 11x, then minus del x of 12y. So when you have this now, what's the next thing to do? So now let me explain this clearly. If for you to differentiate x cubed partially with respect to s, it is very possible because I have x to differentiate here. Okay, so differentiate x successfully, that will give us 3x squared when you differentiate x cubed. Now here in this case, now it is totally different from this one. This one is just a single term. Now this one is a single term with product. That is, 2x squared is multiplying y cubed. So I will advise you to use product rule. Let this represent your u and let this y cube represent our v, such that you apply the rule of product rule, which is uv prime plus vu prime. I advise you to do it this way. So we do it one by one. Remember, we will still have to differentiate this v prime partially with respect to x. So please remember that. So then next thing for us to do from here is to do the next one, which is differentiate 3y squared partially with respect to s. Since there is no x to differentiate, all this thing becomes 0. Please take note of that. There is no x to differentiate, everything here partially with respect to s. No x to differentiate, everything becomes 0. Then here in this case, differentiate 11x partially with respect to s. So it's possible. Since there is x to differentiate, I have 11. Then minus differentiate 12y partially with respect to x. There is no x to differentiate, then we have 0. So hence we have 3x squared plus, now let's substitute. What is u? U is 2x squared, right? And what does v prime means? V prime means differentiate v partially with respect to x. So differentiate, do you see that? V partially with respect to what? X. And you know I'm not supposed to write v. V itself is what? Y cubed. Y cubed. Do you understand that? So v itself is y raised to the power of 3. So that means I want to differentiate y cubed with respect to x, which is not possible. There is no x to differentiate, everything becomes 0. So I'll come back for that. What is our v? V is y cubed. Then u prime means differentiate 2x squared partially with respect to x. Differentiate u abi. That is differentiate 2x squared partially with respect to what? With x. So that's how to work it out. Then plus 11. Then the next thing for us to do from here is to write 3x squared plus. Now let me explain this clearly. V prime means differentiate v, and v is already y cubed. See it here. With respect to what? Partially with respect to what? X. And trivially, differentiate y cubed partially with respect to x is not possible. That's 0. 0 times this, that gives us 0. Do you understand that? And then here in this case, I have differentiate 2x squared partially with respect to x, and that is 4x. Here to be 4x times this y cube, that's 4x y cube after differentiating plus 11. So therefore we end up having 3x squared plus 4xy cube plus 11. So this end up giving us the final answer for del g del x. So g is standard, so that's how it works. And as for the next question, which is what b part. So for the b part, we just decide to, so for the b part we have question b. We are asked to but before I go straight to question b, let me just take, let's say we have we have actually tried del g del x, but what if you now have del g with respect to y? So that's another question entirely. So you go through the same process that I've done here. So then that means I can write this as del y of this g that I have here, which is g in terms of x and y, and therefore I will have del y of what? The function g given to me from the question is x cubed plus 2x squared y cubed minus 3y squared plus 11x minus 12y. G is standard. So therefore from here we can easily differentiate, right? Partially for each term that we have there. So I will have del y of x raised to the power of 3, okay, plus del y of 2x squared y cubed minus del y of 3y squared, right? And then plus del y of 11x minus del y of 12y rather, of 12y. So from here now, since we have this, we can start by saying we have differentiate x cubed partially with respect to y, then trivially that should give us 0. There is no y to differentiate, so you should know that that will give us 0. Okay, then plus having this now, since we already have del y of this 2x squared then y cube, that means we have to use product rule. Let this represent u and let this represent v, such that we have u v prime plus vu prime then with the rest. So since we have u v prime plus vu prime, we can easily differentiate this using product rule, and then this will give us 6y plus this will give us 11, right? And this will give us 12. But this is 11x. I want to differentiate 11x partially with respect to, that's 0. So be very careful of that. So that's 0. So hence we end up having 0 plus, this is u is 2x squared. So you do the same thing applicable. So we have uv prime